So welcome back. Today we do limits part 2, then we'll start now. Welcome back. I can't say anything else. So let's begin. So welcome back. Today we again continue with calculus, and I will do one limit sum. Let's check if you people can do. F of x equal to x square plus x. You have to find what you have to. Let's say you do x tends to 1. Limit x tends to 1 f of x. What is this? This is the welcome question for you all. Okay, welcome question for you all. So take 5 minutes, not 5 minutes, take, I'll count till 5. Okay, 1 2 3 4 5. Now one thing you do, always 7 such sums I gave, please pause the video and try them yourself. Okay, now it is if you can do this, you approach from the left, approach from the right. Remember these things. So I will approach from the left this time. Okay, x tends to 1, so I will take values like 0 0.9, 0 0.999, then 0. Let's say 99. Okay, I think I should not do like this. Let's change this. Okay, like this. So values for these come, means this is the x, then f of x has come 1.71, 1.9701, then 1.997. okay, you can see it is slowly going towards 2, going towards 2. Now if you go approach from the right side, you will see, let's say 1.01, 1 will approach from the right side. No, yes, 1.01, 1.1, 1.2. So if you approach from the right side, you can say it is coming 2.64. I have actually calculated these values beforehand. Okay, so I can write it. Okay, you have to calculate for now. Later there are shortcuts. Later how to solve limits we will do. That time you do. But now for basics you need to do like this. So as you can do, it is also going towards 2. I should not write like this. 2. So I can say what the limit is nothing but 2 here. Okay, 2 is the limit. 2 is the limit of this function where x tends to not 0, once again 1. Understand this? Now this is one example I did, and that types of this type of functions also, like f of x is equal to some value like this, some value for some condition, for some condition, for some condition. This also I did last day. Now let's talk about algebra of limits. Okay, if let's say limit if limit x tends to a, f of x, any operation. Okay, any operation, star means any binary operation. Okay, g of x will be nothing but limit f of x, x tends to a, that binary operation, I can't draw a star, then limit f, once again, why can't I write today, limit g of x, x tends to a. Okay, so if I say that what is limit x tends to a, limit x tends to a, let's say f of x plus, not plus, let's say into g of x. Okay, so what you can do, you can just write limit, once again, limit f of x, x tends to a, into limit x tends to a, g of x. Okay, for anything like division, sum, difference, product, all 4 operations. Okay, now if we have, let's say if we multiply a scalar vector, like means scalar thing with that, let's say limit some constant, this lambda, let's say lambda is a constant in our case, lambda into f. So if we have lambda into f of x, okay, so we can extends to a again, so we can write it that we can bring out the lambda, then do the limit extends to a f of x. Okay, if there is any scalar. Okay, now let's say we have a polynomial function. So let's first, before that, let me tell you, if limit x tends to a x, what will this be? A. It will always be a because the function is x only. So if we approach from the right, it is going towards a, and if we approach from the left, it is going to a. If we approach from the right, it is also going to a. You can do it on your own. It's a self exercise now. Okay, so this is a. So now limit, let's say x square. Can you tell me what this is? This I can write what? Limit x tends to a x into x. This can be two different individual functions. So then I can write what? By earlier things, I can say limit x tends to a. Okay, limit x tends to a x into limit x tends to a x. So we can do what? A into a. What is that? A square. So in that same way, now let's say we have n values, so I can write what like that. If we have, let's say, limit x tends to a, we have x to the power n. So we can do what? We can write it as limit x tends to a, then we will do x into x. It will go on till x. This will be n times. Okay, n times. Like this it will go. So individually I can break that many times. So I can write limit x tends to a x into so till the last one. So how many there will be? N times. Okay, n times, and each of them is nothing but a here. So I can write what? It is equal to a to the power n. So I know now a very important formula. Limit x tends to a x to the power n is nothing but a to the power n. Understand? So now if I have, let's say, limit, sorry, why am I writing function? If we have a, okay, I'm writing function only. Function, a polynomial function. What is that? This thing you remember? This is what is a polynomial function. Now if we find out the limit of this function, let's say x tends to a, then what will it be? I can write limit x tends to a, then a0 plus a1x plus till a n x to the power n, one second, a n x to the power n. Okay, can you see the thing? Okay, can see it. Limit. Okay, so this thing I can break it individually, like in what do you call it, the limits. Understand? So limit x, let's say limit a0 x to the power a, then limit a1 x to the power a, plus so on, limit x to the power x tends to a n x to the power n. Now what do we know something about this? That we can take out always the constant term. I can take it out. Okay, now limit of 1 is obviously 1. Limit of any, okay, let me tell you this. Limit of any constant, let's say, okay, 1 is always that constant only. Okay, constant. I'm writing, not why I'm writing 1. Limit of any constant is nothing but 1, because see why you would say this. Let's say we are approaching from the right, okay, approaching from the left. Okay, so it will always converge at this value c. Okay, and if we approach from the left, sorry, if we approach from the right, we can also see it is again converging at the value of c. So we know what limit that y has to converge at the value of c, and it is converging, so that c is nothing but my limit here. Understand? So in that way I can write this will be nothing but a0, then take out the constant a1, so I am left with limit x it tends to a1, then I am left with what, limit x tends to a, that is nothing but a, then I am a2, let's say, then what do I have, limit x square x tends to a, that is what, a squared, remember a squared because we learned it now only. So next we'll go, then obviously an, then x to the power n, sorry an, then limit x to the power n means limit x to the power n x tends to a, this we just learned, that is it is a to the power n, so I can write a to the power n. So I'll just erase this now, this part, okay, this part let me erase. Okay, so this thing is nothing but my function of a. Can you see this? Can you see this? This is nothing but my function of a. This is nothing but my function of a. So, because function of a is what? This thing only, no? This thing only. This is nothing but my function of a. Okay. So we learned a very important thing, that if f of x is a polynomial function, then limit f of x x tends to a is nothing but f of a. Understand this? Then it is nothing but limit if f of x x tends to a, then it is nothing but f of a. So remember the earlier sum we did, let's say what was the earlier sum, can you remember what was the earlier sum? It was f of x, I did that sum exactly for this reason, x square plus x, my answer came out to be 2. Now let's say limit x tends to 1 x square plus x. Okay, so if this is my function, okay, this is my f of x, I have to find out my f of 1, f of 1, because here a is 1, so f of 1 is nothing but 1 squared plus 1, that is what, 1 plus 1, that is 2, so this should come 2. See, the answer is 2 only, matched. So now you're using that like long method. Now earlier you used that long method, approaching from the left, approaching from the right, but now you can see clearly we have a formula for polynomials. So any function like this, polynomial functions, you just apply it, you apply it. So I think I'll end it here. So the end.